Okay, let's talk about graphing nonlinear equations. So you may be wondering, what is nonlinear equation? So far we learned how to graph a straight line. So nonlinear equations are equations that are not a line. So we will learn how to graph the four types of nonlinear equations. First one has the form y equal to ax squared plus b. A and b are constants. A is not equal to 0, okay? Because if a equals 0, 0 times a variable is 0, right? If a is 0, y equals b. That means you have a linear equation. So make sure a is not 0. And the shape of this nonlinear equation is look like parabola. This is open up or close, open down. And number 2, y equals a to the third power plus b. This nonlinear equations, a and b are constant. A is not equal to 0. Again, if a is equal to 0, this term right here is 0. That means y equals b, and you have a linear equation. So this condition right here guaranteed this is not a linear equation because a is not equal to 0. And the shape of this nonlinear equation is increasing to the right or increasing to the left. Number 3, y equal to a over x. A is a constant. A is not equal to 0. Not only that, x is also not equal to 0. So I have a x not equal to 0. Okay, so both a and x are not equal to 0. If x equals 0, it means undefined. Remember, for division, you don't want anything divided by 0, because if it's divided by 0, it's become undefined. It won't be an equation. So a is a constant, ax not equal to 0. And then the graph is going to be something like this. It will appear on the opposites of the quadrants, either quadrant 1 or quadrant 3, or quadrant 2, quadrant 4. And the last one is y equal to absolute value of x plus b. B is a constant, and it has, the graph is like V shape, okay, or moving somewhere else away from the origin. So these are the four nonlinear equations that we'll learn to graph. And I know it's difficult to graph a nonlinear equation. I would strongly recommend you to remember or memorize the pattern. Like if you see y equals ax squared plus some constant, it's going to be in this shape, okay? This shape or this shape for y equals ax squared plus b. So memorize that. And when you see y equals ax to the third power plus b, it's going to be some shape like this or like this, okay? Memorize this, help a lot. And same thing here, y equals a divided by x. The shape is going to be either quadrant 1, quadrant 3, or quadrant 2, quadrant 4, okay? And the last one, when you see the absolute value, it's going to be a V shape, okay? This one is very straightforward. So memorize it, please. If you memorize it, the graphing becomes less complicated. It's very helpful. I strongly recommend you do that. Now, unlike a linear equation, to graph a line, all you need is 2 points. Minimum 2 points to graph a line. To graph nonlinear equations, you need more than 3 points. I would say 5 points average, usually. Sometimes more. So, for these, let's see what I say here. I would say usually take at least 3 points, more than 3 points for sure. Can be 5. Make sure I want to stay consistent. Yep, usually plot more than 3 points. So let's start with an example. So for this example, graph y equal to x squared minus 1. Now, we saw this equation, right? So we know that it's not a linear equation because it's raised to a power that is more than 1. A linear equation is something like ax plus b or ax plus by equals c. So for linear equation, okay, linear equation, all the variable raised to only power 1. Okay. For nonlinear equation, it's raised to a power more than 1, bigger than 1. So we know that if given this equation, you know that right away it's not a linear equation because the power is greater than 1. So now, when you see this problem, next, I hope you would think about which one of the 4 this equation belongs to. Is it the first one, second one, third one, or fourth one? Let's look at the first one. Y equal to ax squared. We're given y equal to x squared minus 1. So actually, it is this one, right? Not this one because this raised to the 3rd power. Not this one because this is a quotient. Not this one because this involves the absolute value. So I know that the graph is going to be something like this or something like this. Open up or open down. I don't know yet. But I know it patterns. The patterns. So let's put a hint, something like this, okay? Either this or this. Thinking about same procedure. We graph by plotting points. Now this time you need more than 3 points. So I would say probably start from 0. Okay, let's start with 5 points right now. If we need to, we'll make more. So when x goes 0, y equal to, substitute 0 for x, we get 0 minus 1 is -1, right? 0 squared is 0, minus 1. 0 minus 1 is minus 1, so minus 1 for 0. Okay. When x goes to 1, we get y equal to 1 for x, 1 squared, subtract 1. 1 squared is 1 subtract 1, which is 0. Okay, so when x equals 1, y is 0. And let's see, x equals 2. Substitute for x. 2 squared is 4, minus 1. 4 minus 1 is 3. Okay, so when x equals 2, y is 3. Now let's draw with these 3 points first to see if it helps, okay? So when x is 0, okay, right here, where both intersect, when x is 0, y is -1, so it's negative, it's going down 1 unit. Somewhere here. When x equals 1, y equals 0, some point here. So when x equals to 1, y is 0. Third point, when x equals to 2, y equals 3, so 1, 2, 3, somewhere up here. Okay. Do you see that with 3 points, it's kind of hard to know how this graph is going to look like, right? So it looks like you're going to need more points. Now, in the future, the more you see this, maybe 3 points are good enough. But for now, if you don't see yet the pattern, that's fine. Go more, just find more points. It will help you to see the pattern more clearly. So, and sometimes it's helpful too to go on the other side of 0, not just one side. Because remember, sometimes if it kept going on this way or this way, you'll know that which side it's on. So I would say graph the plot, substitute opposites of what the value you have right here. So opposite of 1 is -1. Opposite of 2 is -2. So let's start here. When x equal to -1, we got y equal to -1 squared, subtract 1. -1 squared is 1, minus 1, which is 0. Okay. And x equal to -2, y equal to -2 here, you get -2 squared minus 1, simplify. -2 squared is 4, subtract 1, so it's 3. 4 minus 1 is 3. Okay, so let's see how it helps. So now we know when x equals -1, somewhere here, y equals 0. Okay? And when x equals -2, y equals to 3. 1, 2, 3. So somewhere here. Alright, now we have all the points. This point, this point, this point, this point, this point. Can you form a pattern? Is it going to be open up or open down? So I connect it. Yep, so it's going to be open up. Okay, after we connect all these points together. So this is the graph of the nonlinear equation y equal to x squared minus 1. Okay, let's try a different example. So we graph y equal 3 minus x squared. Again, which one is that? One of the 4. This one, right? Because x squared. It just write differently. It just write, instead of b here, after the variable, it just write b before the variable. B is a constant. But it has the same format, okay? Just rewriting the two terms. We can graph this by drawing a table. X, Y. So again, to graph this, I would same thing. I would recommend going between 0, 5 point with respect to 0. So when x equals 0, okay, y equal to 3 minus 0 squared, which is 3 minus 2. 0 squared is 0. 3 minus 0 is 3. Okay? When x equal to 1, y equal to 3 minus 1 squared is 3 minus 1 squared is 1. 3 minus 1 is 2. So when x equal 1, y equal 2. Okay? And then when x equal to 2, sorry, this is part 2, should be in the order of increasing number, minus 2, minus 1, 0, 1, 2. So when x equal to 2, y equal to 3 minus 2, 2 squared, equal to 3 minus 4, 2 squared is 4, 3 minus 4 is minus 1. Okay? Let's grab it first, see how it's like. Let me make the line more straight. So when x equals 0, right here, y equals 3, go 3 units up. Right here, this point, 0, 3. When x is 1, y is 2, 1 up 2, right here. 1, 2, When x equals 2, y equal to -1, somewhere here. Okay. So far you have 3 points. The question is it going to open up, open down? Alright, but 3 point may not be enough, so let's try to plug in this point. Now, if you notice that this equation is raised to the second power, so guarantee whatever value you plug into x right here, it will give you a positive number, okay? So you plug 1 here, 1 squared is 1. Simplify, you get this value, which is 2, right? What if you plug -1 into the x? -1 squared is positive 1. Simplify, you should get the same value like when x equals 1, which is 2. Okay? Same thing. When you substitute this value for 2, right? For x, when you square it, it becomes 4, right? What if you substitute -2 in here? -2 squared is 4, so guarantee you still get the same value, -1. Okay? So when you substitute -1 here, square still 1. When you substitute -2 here, square is still 4. Guarantee same value. On the other side, okay, on the other side of 0. So for this type of nonlinear equation raised to the second power, this will be true. It's not true for other cases, but for this case, the value with respect to 0 on the bigger side or the smaller side, they will use the same number for nonlinear equation that raised to the second power, like this case. Okay? So now we have 2 more points, right? We can graph when x over -1, we have 2, 1, 2 up. So it's -1, 2. And -2 here, we have -1. So now we have this point, this point, this point, this point, this point. Do you see the pattern that's going here to here? Okay. So it's open down and it's symmetric. So this side will be the same as the other side. It's symmetric. It's symmetric when x was 0. Okay. See that? It's symmetric. This side should curve the way that this side would curve the way the same as the other side. The 2 curves should have the same pattern, symmetric, just like mirror of each other. All right. So that's one example. Let's try a different example. Give you a moment to see it. Graph y equal to 3 over x. Okay? Now, yes, this time y and x to the first power, right? It almost looks similar to a linear equation. Okay, this looks almost like, right? Because x raised the first power, y raised the first power, right? But the problem is that they're not on the same, like same numerator or same denominator. This y is on top, numerator. This is below, in the denominator. It's not on the same line. Okay, so it's not a linear equation. So this is not a linear equation. It's not a line. So which nonlinear equation is that?